So benchmark tomorrow. Now this is just for people who did not make an A on both tests. So if you made an A on the first trig test and you made an A on the test that we took the other day, then you don't have to take the benchmark. You can, it's optional, but here are the topics. First two questions, there's two trig graphs. Okay, that's either tangent or cotangent, secant or cosecant. There's not sine or cosine on there. Okay, so much like the test that you just had. By the way, these are all multiple choice questions. Right, 15 multiple choice questions. All right, the next 4 questions are solving trig equations, which is exactly what you just took a test over. Solving trig equations. The next 4 questions, there are 4 inverse trig functions. That's where you either see arcsine or maybe sine to the -1. Those are your inverse trig functions. There are 2 matrices questions. Now, they're multiple choice again, but there are 2 matrices questions. There is one question that asks you to solve for an angle given 2 sides. And here's my example question. So it tells you that you have a triangle, and it says angle whatever is a right angle. So when you draw the triangle, you're going to label it like they tell you to label it. Okay? And then it gives you the measurements of 2 sides. So after you've labeled the one angle that they tell you is a right angle, it doesn't really matter which way you label the other 2 angles, but then you just fill in the missing information. So let's say that they said A is 3 and C is 15, and they want angle B. What information do you have right here? Think about the perspective of angle B. You have adjacent over hypotenuse. So that's cosine. But I need an angle. You do inverse cosine, 3 over 15. That gives you your answer. Now, I can't remember if the answers on the test are in degree or radian. I think that they're in degree. But the one thing that you need to make sure of is that your calculator is in the appropriate mode. Okay? All right, then there's one that says solve for an angle, one, solve for an angle given 2 sides, and then 2, find exact values of 5 other trig functions given a ratio. That, I believe, was on your test Tuesday as well. So it might say something like the cosine of theta is 2/3, and tangent is negative. Find the other 5 trig functions. And if I had to guess without looking at the test in front of me, I bet they've rationalized their answer. So it would be up to you to recognize 1 over the square root of 5, which is what you might put, which would be okay with me, as square root of 5 over 5. Okay? All right, what do you think? Any questions on what's on your benchmark? Now, if you made an A on both unit tests and you want to take the benchmark, can you do that? Certainly. But that grade counts, whatever you make. It's not a, oh, I didn't do too well, so let's don't count it. If you take it, it's going to count. It counts as a test grade. Okay? All right, so let's talk about questions that you might have from your test yesterday. You guys, I know that there were a couple of you who had a different version, but for the most part, you guys had version 1, correct? Look at the top right-hand corner. It'll say like ID something. You have 4. You have 4. Anybody else have a different version? What do you have? You have 1. Okay. All right. So let's look at number 15, because this is the one that seemed to cause the most problem. Version number 1, problem number 15. All right. So negative tangent of theta equals cotangent of theta plus root 3 cotangent of theta, tangent of theta minus tangent of theta. Okay, what do you want to do on this one? What's my first step? The negative tangents cancel out. Are we all agreed on that? Why does that happen? Negative on one side, negative on the other side. If I added either direction, they would be gone. Okay, good. So now we're down to 0 equals cotangent of theta plus root 3 cotangent of theta, tangent of theta. All right, what do you notice? I can take out a cotangent. So 0 equals cotangent of theta, I'm sorry, not plus, cotangent of theta what? Parentheses, what? 1 plus root 3 tangent of theta. Okay, and that's all I can do, so now I can solve the problem. So here we get to the part where a lot of people miss the boat. So 0 equals cotangent of theta. Okay, where on the unit circle is cotangent 0? Pi over 2 and 3 pi over 2. All right, keep that in your head for just a minute. Now let's go over here and do 0 equals 1 plus root 3 tangent of theta. Now what? Move the 1 over, so negative 1 equals root 3 tangent of theta. So negative 1 over root 3 equals tangent of theta. And what's another way for me to think of that? Negative root 3 over 3, negative root 3 over 3 equals tangent of theta. And so early in the year we said 30 degrees has all the 3's. 60 degrees is just root 3, so this must be a 30 degree. And so I put my 30 degree finger down, and that means I've got pi over 6, but I need it to be negative. So 5 pi over 6, and what's the other one? 11 pi over 6. Okay. I don't know how many of you have listened to me when I've said to you that you can check your answers when you're finished. How would you check your answers when you're finished? You can plug them back in. Okay, so here we get to the point where a lot of people put pi over 2 and 3 pi over 2, and I totally understand why you did it, but I want you to take just a minute and plug pi over 2 as theta into just the left-hand side. Negative tangent, let's just try it, pi over 2. It's undefined. So that can't happen. That answer is not valid, so it can't count. They're out. You have to think about whether or not your answers will work in the problem. It's just like an algebra problem. If I solve an algebra problem and I actually take my answers and plug it back in, they all have to work. So really and truly, the only answers should have been 5 pi over 6 and 11 pi over 6. You may have received a little leniency on yours if you put those two answers. If you put undefined, that's actually the correct answer. Okay, but did you get all of it wrong? No, you should have just gotten minus something. Each one, remember, each problem had 1 point for the work and then 1 point for every answer that you were supposed to have. Well, you really and truly, you just could have marked those two answers out. So you put undefined. All right, well, did you get these other two answers? All right, good. So then write me a note at the top and put it back in the tray, and I'll look at it. That's good. Yeah, a lot of you put these two, and I understand why you did it. And some of you even went so far as saying, instead of where is cotangent 0, you actually flipped it and said where is tangent undefined, and then you put pi over 2 and 3 pi over 2, which I get. I get that rationale that you're going through in your head, but the problem is when you plug those back in, they don't work. Because you can't get something that's undefined. You can't set it equal to undefined. It has to be equal to 0 or equal to something else. All right, so what else on here do you need for me to work for you? Or do you want a minute to work with maybe some people around you and see what you can get for yourself, and then you want to ask me questions? Okay, I'll make the decision for you then. How about if I give you 15 minutes to work with somebody around you? Okay, so this is number 8 on the quiz, ID 1. I'm sorry, on the test, number 8. Negative 3 equals 2 cosine squared theta plus cosine theta minus 4. Okay, what should I do as my first step? I should add the 3. Okay, so 0 equals 2 cosine squared theta plus cosine of theta minus 1. Okay. All right. I have a trinomial. I have a squared term, a term to the first degree, and a constant. So that means I need to do what? I need to factor. Okay, what goes in the top? Negative 2. That's AC. What goes in the bottom? 1. So then I need two numbers that will give me a product of AC and a sum of V. 2 and negative 1. Why can I not do negative 2 and positive 1? So this, what I would add, would end up being negative, and I need for it to be positive. Okay? So now what's my next step? Divide by A. So I'm going to divide this by A and divide that by A. Okay, and then I write my binomials from the bottom up. So this becomes 0 equals cosine theta plus 1. And then write this one, 2 cosine theta minus 1. Okay, set each of those equal to 0. So I need to know, where is the cosine of theta equal to negative 1? Where does that happen? Pi. All right. Now this becomes 2 cosine of theta minus 1 equals 0. Oops. And so cosine of theta equals 1/2. So where is that? 60 degrees, and I need for it to be positive. Pi over 3 and so pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. I need it to be in the 4th quadrant. Okay, what else? So do you feel like your errors are algebraic errors or trig errors? See, I felt like they were kind of equal, because a lot of people put over 6s where they should have put over 3s, and over 3s when they should have put over 6s on those that had like 4 answers. You got that there were 4 answers, but you put the wrong 4. All right, what else on the test? Anything that you weren't able to get? Yeah. Uh-huh. Number 5. All right, so this is negative 9 secant of theta is equal to 6 root 3. Okay, what's the first step? So secant of theta is equal to 6 root 3 over negative 9. Okay, so this is secant of theta is equal to negative root 3 over 2. Is that right? There you go. Negative 2 over root 3. That's how you reduce that. Okay, now, if I have a secant, I really need to think in terms of cosine. So this is, where is the cosine of theta? Root 3 over 2. And where is that? It's negative. That's at a 30 degree. So that would be something over 6. So we've got pi over 6, 5 pi over 6, 7 pi over 6. Yes. Okay, so let's just look at the fraction 6 over negative 9. What do you notice is in common about both of those? They're multiples of 3. Okay, so this 3 goes into 6 how many times? And into negative 9. Okay, and then where's my root? Up here? Okay. And so if I flip it, it becomes what? Negative 3 over 2 root 3. And then if I rationalize it, negative 3 root 3 over 6. 2 times root 3 times root 3 is 2 times 3, which is 6, which is negative root 3 over 2. Got it? Okay, what else? That's it? Okay. What about, oh, Jocelyn. Yeah, absolutely. Number 11. All right, so 2 minus 3 secant squared theta equals negative 2 secant squared theta. Okay. So what should I do first? I would add the negative 3 secant squared theta. And so then this is going to become 2 equals secant squared theta. Now what? Not square both sides, but take the square root of both sides. So this becomes plus or minus root 2 is equal to secant of theta. Well, I don't think in terms of secant. I think in terms of cosine. So it's plus or minus root 2 over 2 is equal to the cosine of theta. And where is that? Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay? Anytime you get like just root 2 or root 3 and you need to flip it, put it over a 1, and then flip it that way and rationalize it. All right. So then what do you need to see as a way of practice for the benchmark? What I think would be a good idea is for you to go through your backpack and get out your first test from this unit, your first trig test from this unit, and your matrix quiz. And then put together kind of a list of, I really need to know how to do these. I need to see one of these before I take the benchmark tomorrow, and then I'll work those too. I'll put those on here too. Thank you. Okay, so this is graphing trig quiz. ID number 1, and this is problem number 4. Okay. Jocelyn, or Brianna, this is your, you brought this up here? Oh, you brought it up. Okay. All right, so let's identify some of the things that we need to identify first. Now, cotangent does not have a what? It doesn't have an amplitude, but it does have an A value of 3. So that's going to be important for me to just kind of look at how high that halfway in between point goes up and how low it goes down. Okay. Anything else that you can tell me right away? I do like that too. Vertical shift. Which way? Down 2. Good. All right. So now if it's a cotangent graph, the period is pi. Okay, so pi over k. So we're going to say pi over k equals the period on this one. Okay, that's the formula that you're going to use. So what is k? It's 1/3. So we're going to go pi divided by 1/3, which is going to be 3 pi. That's important. 3 pi. All right. What else do we need to know to graph this thing? I need to know the phase shift. All right. Right away, I can tell you the direction of the phase shift. It moves to the right. Okay. It moves a positive direction because inside the argument's negative. All right, so what's the formula for phase shift? It's negative C over K, or B. Yeah, we've been using B, I think, instead of K, but a lot of you learned it that way. Same thing. So what is C? 7 pi over 6, it's negative, and that would be negative, so that would change it to a positive, okay, is equal to, divided by 1/3. Okay, so how do I do that? 7 pi over 6 times 3 over 1 is equal to 21 pi over 6. That's not an easy one, is it? Okay, well, is there anything I can do maybe to simplify that a little bit? I could take out a 3. I could simplify by 3, correct? So 3 goes into 21 7 times, and then over 2. That's much easier to handle. 7 pi over 2. Okay, do I have everything I need to graph? At this point, I do. Does anybody remember the method that we used to graph the tangent and the cotangent? Okay, so what we're going to do first is just draw this line. And we're going to anchor it right here in the middle. We know that cotangent parent function starts where? At pi over 2. That's where it starts. But this graph shifts to the right 7 pi over 2. So pi over 2 plus 7 pi over 2 is 8 pi over 2 or 4 pi. That's my anchor point. Cotangent graph, the parent function, anchors at pi over 2. All 5 other trig functions start where? 0 pi. This is the oddball. Cotangent starts at pi over 2. So all your phase shifts have to be done from pi over 2. Okay, what was the next thing we did? Well, we can just add asymptotes on either end, right? So we can add this asymptote and we can add this asymptote. Now we know this goes up as high as, we'll see, we had this was y equals -2. And it had an a value of 3. So from -2 up 3, where does that put us? So this would be y equals 1. And this go down a little bit. And that would be y equals -5. Good. Okay. What was the period? Period was 3 pi. I need half the period on the right and half the period on the left. Well, what's half of 3? It's 1.5, right? So what is 4 plus 1.5? 5.5. How do you write that as a fraction, not a mixed number? 11 pi over 2. 2 goes into 11 5 times with 1/2 left over. Okay. Now I need to go backwards. So for minus 2.5, 2.5, which is really 5 pi over 2. Okay. I did not have any sort of reflection, and a cotangent graph goes up on the left and down on the right. So all I have to do is plot a point here, plot a point about right there, about halfway in between each of those. So like right there and right there, and then just connect the points. See, the key thing on here is the labeling of the grid, because once I'm done, if I looked at this one versus another one, and I'm only drawing one period, they all look alike. So a lot of people were missing points because they weren't putting anything here. They just drew the shape of the graph. That's not going to get it. You're going to have to label everything. Okay, what else? That was a good one to do. On the same. Okay, so this is number 3. Y equals 1/2 tangent theta over 2 minus 5 pi over 6 plus 1. Okay? It's the same graph, same quiz, number 3, the tangent graph, which I think are the two that you guys struggle with the most. Yes? Okay, good. This is good to do. Let's just pull out all the pieces. So the A value is 1/2. I'm not calling it an amplitude. I'm calling it an A value because what it does is it shifts that halfway between point up or down. Okay? What else? It does have a vertical shift up 1. Those are the easy ones to get. We'll do those right away. What else? Good. Phase shift would be 5 pi over 6 divided by 1/2. Now, Dylan went ahead and made that positive because in the argument it's negative, so we know it moves in the opposite direction. And so we've got 5 pi over 6 times 2 over 1, which is 10 pi over 6, which is 5 pi. Well, no, because here it's negative, so it moves the opposite direction. Really, the formula is negative c over b. Yeah, so this is all positive. You're good. You're good with positive. So 10/6 reduces to 5 over 3 pi. Okay? Those fractions. All right, what about the period? It would be pi divided by 1/2, which is just 2 pi. Is that good? Do we have it all broken apart? Got all the pieces we need? Excellent. So then we come over here and we just draw a line. And then what? Anchor it in the middle. And we can even go ahead and draw the asymptotes on the end because we know that's what it's going to look like. We had a midline that went up 1, so we could label that as y equals 1. And we had an a value of 1/2, so we have to go up 1/2. So it would be 1.5, or y equals 3/2. Then we have to go down 1/2. Y equals 1/2. Okay, good. Got that taken care of. Now, where does the tangent parent graph start? At 0 pi. All 5 other trig functions start at 0 pi. It anchors at 0 pi. Well, we're moving the anchor how far? Okay, now, what was the period? 2 pi. That means I need half of it on one side, half of it on other, so that means I need to add pi over here and pi over there. Subtract pi. So how can I do that real easily without having to get my calculator out? That's right. So it would be 3 over 3 pi. So then this mark would be 8 pi over 3. And then I subtract it, and this would be 2 pi over 3. And I know that the tangent graph goes up on the right and down on the left. So I just kind of pick a point here about halfway, go up to there, pick a point here, go halfway. And there you go. All right, what else? Okay. Okay. If it's something you want me to look at on your test, just write me a note, put it in the tray. All right, anything else you can think of that would be helpful for benchmark tomorrow? Yeah. Let's do one. Do you have a problem we can work? How about, okay, I'm just going to make one up. Is that okay with you? All right, so let's say that sine of theta is equal to 3 over 5, and tangent is less than 0. Okay? So I need to sketch a triangle. And these are the clues that tell me where to put it. Okay. Sine is positive, but tangent is negative. Tangent less than 0 implies that tangent's negative. So you've got a positive sine and a negative tangent. So what quadrant? Second quadrant. So you build your triangle in the second quadrant. Okay. This is the angle that we're after. That's theta. Okay, well, sine is the ratio of, give me letters, y over r. That's what we got to do. Now that we're in this trig unit, we got to use the y's, the x's, and the r's. So y over r. So y would be 3, and r would be, okay. So then we're missing x. So x squared plus 3 squared equals 5 squared. This is your perfect triple. So this should be 4. But what? It's got to be negative. because it's in the second quadrant. So now we just go through. We have sine. We already know that. Let's do cosine. Well, cosine's the ratio of x over r. So this would be -4 over 5. Tangent would be the ratio of y over x. So this would be 3 over -4. Now, how do we get the other ones? Sine is the reciprocal of cosecant. And so we flip that and it becomes 5/3. Cosine is the reciprocal of secant. And we flip that and becomes -5 over 4. And tangent and cotangent, -4/3. That's it. Make sure that you hold on to the sign. When you flip it, you're not changing the sign, you're just flipping the top to the bottom and vice versa, but the sign stays the same. All right, anything else that you can think of? All right, did you write down the topics that are on the benchmark if you have to take it? Okay. All right, so, all right, Taylor, can you hit the blue button right there on the right? Perfect, that's it.